Hello again, Internet people. So today I'll be showing you how to install an LED strip at the top of your 3D printer. Now there's not much of a challenge in doing this, it's pretty easy. All you have to do is hook up ground and 12 volts to any LED strip and it'll illuminate your printer. So instead I'll be installing an LED strip that has RGB LEDs. And I'll be showing you how to make a controller to make it interface with the Arduino inside your 3D printer. For this mod, you will need an LED strip, RGB or not, and you will also need NPN type transistors. Now these little things act as switches for the electronic system. So the current flows from this pole to this pole, and the signal is the middle pin right here. These are mainly used to give a series of logic to any kind of processor. So using 3 of those, an RGB LED strip, and the Arduino already inside your printer, you can give yourself a full range of colors to use any way you want. And I'm going to show you how to do that today. So if you decide to go the RGB route with this mod, I recommend you get a printed circuit board that you can put this all on, some ribbon cable to keep the wires managed, and then some female and male headers. I do a lot of electronics work, that's why I got so many, but you only need 9 female and 9 male headers to complete the project in the way that I'm going to do this. So we're going to have to change a few things in the firmware to get this to work as well. So in my computer I keep all of my firmwares in the same folder. So in this tab you're going to have a lot of them, but we usually only deal with configuration.h. So in configuration.h you're going to click here, you're going to hit find, which is Control F, and you're going to type in stat_. When you hit enter, there's only one instance of stat_, and that's for the status LEDs. So you'll see that it's got 2 forward slashes in front of it, and that undefines the comment. You're going to take those both out, and that will define temperature status LEDs. We're then going to jump over to marlin_main.cpp. You're going to use the exact same find command in here, and that'll find the same line. So you're going to delete everything between the if define and end if. And you're going to leave a small void. On the first one, it says paste marlin_main. You're going to copy everything that I wrote, and you're going to put that into here. And that will define my version of the status LEDs. And after that's done, you're going to clip over here, go down to pins, and again, last time, you're going to go to find status LEDs, and right under this end if, because this is if motherboard is 67, we have motherboard 33. You're going to take everything that I wrote for here, and you're going to paste it right here. So this only defines 2 pins. This defines 3 on 6, 5, and 4. And these are all pulse width modulation pins on the ramps board. So when you plug into them, they'll be able to go from 0 to 255, giving you an extreme expansive range of intensities you can make these lights. So after you do that, save your code. And once that's saved, we can now move on to the hardware portion of this modification. So if you're doing a regular LED strip, this is the old LEDs that came with my R1. All you have to do is hook up 12 volts and ground to the positive and negative leads of your LED, and when you turn your printer on, your lights will glow. And if your lights don't glow immediately when you turn your printer on, switch the leads, and if they don't turn on still, check the wiring under the board. So the next thing I'm going to do is I'm going to show you the startup code that I developed. So if you set it up correctly, you should see it flash red, green, and then blue. Like this. And then it'll go to white and it'll stay there. And so now I'm going to move all of the circuits from the breadboard to this PCB using my soldering iron. So, just finished my tiny little circuit. You can see it's got the 3 transistors. 12 volts can go from this post to this post. This is one of the signals for the colors, same here and same here. And then all of the transistors are wired into ground on this side over here. So I just got finished with the wiring of the circuit, and so I 3D printed an enclosure for it that it just presses right in. And so that holds the housing for that. Then I built an interface wire that's 4 pins that has a red line on it, and that connects to the LEDs. Red is 12 volts because it's the only difference that there is. So once that's hooked together, on this side, hooks into the controller with the 12 volt lead on the outside, because I have the rail running across the back right here. This is a 5-pin adapter because this was a 9-pin ribbon cable. I split it into 2, and you use this side to connect. Ground is on this side, and ground is by itself on this board. So this now gets attached to a 12 volt and ground source inside the printer, and then this goes to pins 4, 5, and 6. As with any project that I ever do, especially one that deals with electronics, you constantly want to test it as you go through the process before you finally assemble anything, just so you don't have to take it all apart and then start all over again. So before I mount anything inside the printer, I want to test it out one more time. Now, I did this on purpose. I have changed the pin outputs for the LEDs. Because remember, these are supposed to be red, green, then blue. So you notice that green's right, but red and blue are mixed up. So, in the firmware, where status LED red is defined, I'm going to change that to 5 and change this one to 6. So when I re-upload the code, then I should get red, green, then blue. And that means that the whole color array is now organized properly. So instead of manually changing wires around, I can just change numbers in the code. It makes it a lot easier. So if you wired everything up properly, it should look like this when it starts up. Oh, that's so cool! Alright, so I prepared a file on the SD card to show you what it looks like with the LEDs and when it's printing. So, when it's at idle or at temperature, the LEDs will display white. So, if it's heating up or cooling down, you'll see a gradient between blue and red depending on what the temperature of the extruder is at that point in time. And so, you can change what it is when it ends. If you set it to 0, it'll be white when it ends. If you set it to 5 degrees, I put that in the program, it'll stay green. And if you set it to 1, you can see the temperature run down and you can see it do the gradient from red to blue. It looks really cool. So, while this does its small demonstration, I hope this video helps you install RGB LEDs at the top of your 3D printer. If you have any questions about this video or suggestions for future videos, make sure you leave your comments down below. If you like this video and want to see more like it, make sure you click that subscribe button. I sure hope that this helps you get into the world of electronics if you don't have any experience. Transistors are pretty much the base fundamentals of electronics along with relays, so this is a great thing to start out with, especially if you want to get into electronics. And thanks for watching.